that. Don't have time to talk to everybody. Yeah. That'll work. Cool. For right now. I left my little tripod thing at home. We don't have time to talk to everybody, right? We don't have the resources to actually look at the whole population. So instead, we're going to take a sample. So the big thing at the heart of statistics, the reason that some people think there's no reason to have statistics in the first place, which is a bogus idea, is because you've got to take a sample sometimes. Your population is way too large sometimes. You have to take a sample. The minute you take a sample and look at the average age of a sample, what can you really not directly say then that you want to be able to say? I want to be able to say something about the average age of all Gross 1 students. The minute I take a sample, I've got to let go about being precise, right? My answer is not going to be perfect. So that's the heart of statistics. Taking a sample and knowing, for example, what would make it a better study?
Taking more people.
Taking more people, making my sample larger, right? There's other considerations too. If I used you guys as my sample, can you tell me why that would be bad? You're not bad people.
We're all in math. Yeah.
Okay, one thing is you're all in math class.
It varies from night classes.
I love it. This is a day class, right? And why is that a consideration? Who normally takes day classes versus night classes? Younger people. And we're talking about average age, right? So normally younger people, or in the whole, normally younger people take day classes. There might be something about 160 is an intro stats course, but it's a transfer course. So there might be some other thing that skews the age data there. You guys with me? So a big part of chapter 1 talks about how do you pick a sample to make sure that you've minimized the possibility of those things happening. So if I wanted you guys to be my sample, do we all agree that that would be a bad sample? Not because you're bad people, but because you are a select group of the population. What's a better way to pick a sample than to do what I want to do? Okay. Take a few people from each group. So be more specific. Hold up.
And then go to like a place where everyone passes by, or most people pass by.
Got you. Okay. So one way would be to go somewhere where most people go by.
Library.
Be more specific though. Go. So go to the library maybe, or stand outside the library. And how do you take care of the day-night thing?
Ask her here different times of the day.
Different times of day. I like it. What are you still not catching though? Do you realize that still isn't a good sample?
It's online students.
Online students, right? Students who don't go there, right? So who's got even a better way to do it? Anybody can think of a better way? Yeah.
If you're able to randomly pick students' ID numbers.
Okay, so if you have a list of all the ID numbers or names, and you can somehow randomly pick, and that in itself is actually not enough to say, to tell you honestly, but I would accept it. Because one way to do it maybe is to put all the ID numbers up on the wall and start having different people throw darts. You know, blindfold them and then run out of the room.
I would say like a random number generator or something like that.
Okay, that's one way to do it. Remember, the computer left. It became a
I
weird.
know.
But no, that's a good idea. Random number generators actually have been studied, and it's a little bit what they're based on doesn't truly make it as random as we think. But they're, as close as we can get really as humans. To tell you honestly. But do you start to realize when you read a study, and very often, I'm going to show you a very silly study that was done. Very often we'll just read the results, and we'll go, oh my God. Right? It's been shown that smearing eggs over your face makes you 20 years younger. Oh yeah, cool. We don't even say, okay, who do they study? There was 3 people down the street. I don't know. Where did this come from? How many people did they talk to? Where were they? Did they pick a sample correctly? Do they tell you any of that? Not very often. No, and the newspaper especially is really bad about it. They might sometimes tell you, 4,000 people were talked to or whatever, but they won't tell you how they were selected. If I wanted to call people, why would that be bad?
Not everyone has a phone.
Still, not everybody has a phone, right? If I wanted to do an online survey, like I am doing, so already you can tell me you suck as a stats teacher. You're doing an online survey. Why is an online survey bad?
Old people don't use it.
Not everybody has access to the internet. Now, you guys have more access than the average person because you can go into the tech mall. You can use a computer there. So I'm not as worried there. But why would it be like why would I not trust the results of a poll that maybe is on the MSNBC or the Fox News? They are biased in what way? Are they biased? We won't get into that. But the people that go to those websites, are they biased?
Yes.
Most likely. You guys with me? And we're not going to get into the politics because that could get messy. We're not going to get into any of that crap. It's amazing. Nowadays, it's getting to the point where you won't get your hair cut until you know the political affiliation of the hair cutters. You're a Democrat, screw you, I'm not. All right, so sample is a subgroup of the population. So you guys would be a sample, just not a good sample. So what would I do then? Once I got the sample selected, once I've randomly selected, thrown darts at a computer, generate numbers, what do I do then?
Add up everybody's age.
Well, before I do that, I've got to get their ages. I've got to actually get a list of data, right? So in this case, I'm going to throw in one more thing right now that they don't have up there. So this is in addition to that list. The variable in this case is related to the question you ask. Does that make sense? Because what's a variable? Why is it called a variable?
Because it varies.
Because it varies. Because x is your variable from algebra, right? So a question is a type of variable because the answers will vary. So the variable is related to the question you would ask. So in this case, what's the variable?
Age.
Age of student, right? So variable in this case, age of student, is related to the question you would ask. And then what's the data in this case?
Their ages.
The answers, the ages. I love it. So part of chapter 1 breaks down the types of data. Obviously, age data is truly numerical data. I can divide them, I can subtract them, right? If somebody's 40 and somebody else is 20, this 40-year-old is twice as old as a 20-year-old, right?
Yeah.
So they're truly numerical data. If I wanted to see the percentage of people that had 258 as the first first three numbers in a social, is the social security number truly numerical data?
No.
No. If I subtract two social security numbers, does it really tell me something? Well, your social security mine is 4. That doesn't tell me anything. Yeah.
So the data is pretty much the value of the variable.
I like it. The value that the variable attends. A list of all the variables' values. So if you like algebra, that's one way to kind of put this so it makes more sense mathematically. If you don't like algebra, then you got that's the question, these are the answers. Right? Statistics really kind of straddles that well, the math world and the less math world, the English world. Okay. Blah, 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 blah. I think you all know what a census is, right? We just went through one back in 2010, and they keep coming out with new reports as they analyze that data. Last semester, my final exam, I had the students do a study that I don't think anybody had ever done before, based on sample data from census, based on census data, right? So it's kind of nifty. You just go into the website and pick some stuff out. See, I think I've gotten a little ahead of myself. Oh yeah, blah, 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 blah. Trying to help you guys out without a book. Oh, let me talk about this for a second, and then I want to show you the website. All right, I'll do it like this. I'll show you that website, and then we'll talk about statistical significance. know if anybody's heard of this. This is an actual study that was done that shows that there is a correlation between the number of cell phone towers in an area and the number of births in that area. Now, before anybody says anything, because some of you guys are pretty quick with understanding what the hell's going on, quicker than this is. Let's see, maybe I'll try it. I want to make sure that this has this. There we go. Beautiful. For every extra mobile phone mast in an area, there are 17.6 more babies born above the average. Right, this is a study that was done in the UK, I think, if I remember correctly. The most misunderstood thing from statistics is correlation. Because, now let's start talking about this then. When people find a correlation, if you don't know enough about statistics, you go and write an article and then people get all up in arms. For example, this is not the best example in the world, but there was a big push recently about don't get your kids immunized because the immunization itself can kill your kid, right? And basically walking out the front door every morning can kill you.
Yeah.
So does that mean you should be in your bed? Laying in your bed could kill you because a meteor could come in or a piece of a plane could fall into your bedroom and kill you. So what the hell do? You go ahead and kill you. No. I mean, you might as well just give up. So there was a misapplication of the statistics in that sent people off into their own thing, and there was a bit of conspiracy theory in there too about the government for some reason wanting to kill kids, but you never really understand this stuff. This one is interesting though. It's something we can really get a handle on a lot better. Do you understand the idea here?
Yes.
And this was an actual study. This is truly the true data. And in fact, let me just get a little technical for a second. And you'll understand this whole paragraph here by the end of the semester. But let's see how much we can pick up. So we took publicly available data on the number of mobile phone masts in each country across the UK, so it was the UK, and then matching it against the live birth data for the same counties. When a regression line is calculated, so we don't know what the hell that is yet, but it's basically what's called a best fit line. When we fit the data with a line, it has a correlation coefficient of 98.1 out of 100. The closer you are to 100, the better, basically, right? 100 would be a perfect correlation, right? So it's really close. To be statistically significant, holy shit. Some words in the stupid math book were actually up in the real world somewhere. That's crazy. To be statistically significant, a pattern in a data set needs to be less than 5% likely to be found in random data known as a p. Oh crap, now we start to get into the technical stuff, right? This piece here, let's see if you guys can get this. If it's less than 5% likely to be found in random data, that's the part that we're going to really try to get into this semester. If I took a sample of people, right now, if I go out and take a sample of people and find that in Grossmont, and find the average age there is 70, right? And I did a good sample, as best as I could. I took a random sample right now, later in the day, different places, different classrooms, online, offline, all this stuff, right? And I find the average age to be 70. Would that be impossible to happen?
Not really.
It's not impossible, is it? Is it likely that would happen? And now what are you basing that statement on? By looking around, you know that the average age here is not 70. Right? But it's not impossible for that to happen, is it? So if somebody took a random sample of Grossmont, they found an average age of 70, they would have to they'd have to look and see, well, how likely would that be to happen? It would be very unlikely to happen, so that it can't be 70. It's not going to happen. To be statistically significant evidence of something, it's got to be really unlikely for that to happen randomly. Okay, maybe. We'll come back to this idea later. So this is really significant. It's statistically significant. It's really unlikely that it just happened randomly. It seems to actually be true. So what actually is going on here? Did I go too far up? Oh shit, I did go too far up. What's going on here? Is anybody that didn't read that last paragraph? Yeah.
If I were to guess, it would be that cell phone masts are usually
That's actually one thing that somebody commented on.
And birth rates in poor communities are probably higher because they have less access to
I see.
birth
Okay.
control.
That's one possibility. Where would you need a cell phone mast more?
Higher.
Where there are more people.
Yes. Population density.
When you have more people in an area, what two things that are important to the study will happen? They will put up more cell phone masts, and since there's more people, there will be more babies. Do you see how this is one way correlation can be confused. There is one factor behind the scenes that's affecting both of the factors that I looked at. All I saw was there's a lot of cell phone masts and there's a lot of babies. Oh shit. There's like cell phone radiation making people fertile or horny or whatever. Right? You guys with me? You understand? And that's obviously crazy. There's some third factor. Another really good example from the book, I like this. I think it's out of this book, out of this edition. There's a researcher who went and watched people play basketball, and he said, wow, so playing basketball makes you tall. Interesting, right? And that's a little more direct. That's not a third factor necessarily. What's the true causality there? So correlation does not mean one thing definitely causes the other. Normally, I don't know which way it goes. In this case, we know which way it goes. Does playing basketball make you taller? No. Being taller makes it a little more likely that you will play basketball, right? There are always exceptions to any rule we come up with, but it's very true that basketball players on average are very freaking tall. When they come off the court and stand next to their reporter, you're like, whoa, holy shit. There was Spud Webb. Anybody remember Spud Webb? I remember Spud Webb fondly because he gave me, I love basketball. He gave me so many, I felt like there's a chance for us guys who would be knocking on their knees. Hey, there's a chance for us little dudes, but oh well. Okay, anyway, so one thing I really like about this, I'm hoping some of you guys get interested in looking behind the scenes. If you see an article and there's like a little reference to where it came from, I'm hoping some of you guys will actually go and take a look. If you're interested in that thing, you want to see where it came from, and they're probably going to have a little more information about how they selected their sample. Let me show you one other website that I love. Have you guys ever heard of Gallup.com?
Yeah.
And the one reason I love this website has nothing to do with any politics or anything, whatever. The pure simple fact, and let me see if I can find something very quickly. Okay, Gingrich erases, even if you don't like politics, you probably should keep up a little bit on who might be our next president. So I'm sure you guys, yeah, or Ron Paul. I'm not going to talk about whether I vote for him or not, but he really doesn't get much respect. Some of his ideas are awesome. Some of them, I'll leave that alone. Let me see here. Let me see. Oh, so you got all this data. Look at all this crazy data. It goes back to December. What was going on and where the hell have they gone? And I used to love when Rick Perry had this image like, wow. Because he should have just stayed home when they had that debate. But if you go way down to the bottom, here's what's missing in most things. Survey methods. Results are based on telephone interviews. So they tell you right there, yes, there might be a problem with our survey because we did our own telephone interviews. As part of blah, 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 a sample of 1,221 Republican registered voters, because of course this is all about the Republican primary. So they tell you exactly what their population was, how they picked their sample. They go into, let's see, where's the, here. You see this all the time. Plus or minus 4 percentage points, or plus or minus 3 percentage points. We'll actually be able to see in the formulas that we learn in here where the hell that comes from. They don't just go, I'm not really sure, let's just put plus or minus 4 down there. Cover our ass a little bit. We'll see in the formula where the hell that comes from. And one thing it's based on is something you guys brought up earlier. To be more sure about something, we would raise our sample size, wouldn't we? So the bigger our sample size, the smaller that number becomes, the less uncertain we are about what we see, of course. And you see it in the formula. It's silly. It's kind of nifty. Okay. So I think That's a decent, I want to let us out of here just a little early today. That's a decent intro. What I need you guys to do, how much homework do you have to do? As I knock my phone over.